But guys, remember what we're going to do now. We're going to mix questions on not this term so badly because you haven't done momentum yet, but you can get momentum, kinematics, Newton, everything in one question. So at the moment you've got Newton, yeah. At the moment you've got Newton and you've got kinematics. So they can be mixed. So here you also know that if net is going to be equal to 0. So that means forces up equal forces down. Please remember that. Okay, so all of that stuff you know by just seeing the word constant velocity. Now, let's see what the question is saying. When you get a question like this, make sense of what it's doing first. It says a hot air balloon is rising at a constant velocity, rising. So what has this question already decided for you? What is up? The question decided for you that up is positive because it's starting here with +8. No, well, if you want to do it for yourself, it's a good habit to do because then you stick with that for the rest of the question. Don't go and change it. Because if up is positive, then g, which is gravitational acceleration, would be negative. So always think through those things when you get a question. Okay, then it says the tourist leans over the edge and accidentally drops his camera. Now, as the hot air balloon is going up, the camera is going up. So at what speed was the camera going when the tourist dropped it? At 8 meters per second. So it says here, what velocity was the balloon ascending at? So that's just checking that you know that the balloon and the camera is going at the same velocity. I only have one more, but you've got the book. You've got this. It's on page 30. Page 30.
How far the camera fell to work out how far the was.
Okay, so then in the next question, so please remember, if I was you, I would draw a little diagram for the camera, because you know the camera goes up first at 8 meters per second, then it stops, and then it falls down. No. If okay, guys, you can even see it. I'm going to move my hand up, and while my hand is moving up, I'm going to open it up. So the pen, if my hand is moving up at 8 meters per second with the pen, what is the velocity of the pen right now? So as it's doing that, I'm going to open my hand. Can you see what the pen's doing? It has to go up, stop, and then come down. It can't just magically start going down. That's why it's positive. So this is plus. Then it's going slower, slower, slower. When it crosses here, what is that always? Where? So here you can literally say that is V at the top. Then it goes faster, 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 and it always hits the ground at its maximum velocity before it bounces for the first time. You guys? So it hits the ground there at 32.28 meters per second. Now let's see. It says, how high was the balloon when the camera was dropped? So do I have information for the balloon? So if you look at the balloon, the only thing that you know for the balloon is that it's going at a constant velocity of 8 meters per second, but that you know nothing else. So you don't have enough information for the balloon. But you know that the camera and the balloon at this point, when the camera was dropped, was at the same place. So this was camera and balloon. The camera did this. The balloon just kept on going up. But this displacement here is the displacement for both of them. So what they're actually asking you there is for delta x for the camera because it's the same as the delta x for the balloon. So you're going to see, okay, what have I got for the camera? I want delta x. I have VI is what? Positive or negative?
Positive, yeah.
Plus 8 meters per second. What else what is VF?
Negative 32,28.
Minus 32,28. Can I work out delta x?
Yeah.
What equation? Do I have the time?
No.
I do.
Yes, you do.
Yeah,
Guys,
we
you've got a
don't-
graph
we don't need
from
to-
0 to 411.
We don't need to use it though,
Why not?
because there's another equation that you can use at that time.
With delta x, v, and f.
With VF equals VI plus.
If you're going to go and work acceleration, with acceleration, you need to calculate it first. We can't assume 9.8.
Why?
They didn't say so.
Well,
They
no,
actually, I lie. They did say
they
air
just say
friction
ignore
can be
air friction.
ignored. Yeah.
So can we use 9.8?
But they maybe tomorrow we tell you to use the graph.
Okay.
If it says use the graph, then you need to use the graph. So you need to then say, okay, t is equal to 4,11 seconds. Can we do this question now?
Yes.
Yes. So I want delta x, I don't have a, so the equation is?
Man, we still don't have data.
Mm-mm.
But you said air friction. Were we saying?
I'm just saying if the question said use the graph to determine. Okay, so then you're not going to do that. So now we're going to use the graph to determine. So what equation are you going to use? Which equation doesn't have?
Delta x equals VF plus VI over 2 times 2.
Now be very careful. When you use this equation for things that are moving up and down, I've seen this messed up a lot of times. You need to put the directions correctly. So VF here is, I'm going to just do it right there. VF is the minus 32, VI is plus 8, divide by 2, and then times by t. I'm just doing this because of space. So it's minus 32.28 plus 8 over 2 times by 4,11 seconds, and it gives you delta x.
49,89.
49,
No, 49,90.
Man, you get the same answer if you use minus 9.8 as your acceleration.
I
No, I
know.
got negative.
So for this question,
I got
you're just
negative.
saying if.
You could have done it, yes.
I got negative. No.
Yes, you should have gotten negative. Because did the camera fall down or up? Down, and we decided that up was positive. So the camera fell down. So now you go and answer the question. We've worked out delta x for the camera, but the question says, how high was the balloon when the camera was dropped? So then you're going to say, therefore, the balloon was. Always go and answer the question. 49,9 meters above the ground. And height is never negative. So if you left your question as negative, you will lose a mark. Okay, because it's not about the camera. The question is about the balloon. Now this little time there, it says how long was the camera in contact with the ground during the bounce? Okay, so you're just minusing those two values, and that is 0,2 seconds. And then they say calculate the value of x. X there. X is a time, guys. Now remember, if it's free fall and there's no friction, the time up must be equal to the time down. So, too much talking with me. So here it's leaving the ground. So V max is when it hits the ground. But there, as soon as it goes positive, is where it leaves the ground. So the in-between time there is the acceleration while it's on the ground. Because that, you can see that line. Where's the ground pushing it? Up or down? Up. And we said up is positive, so it makes sense that that gradient there must be positive. Okay, so it leaves the ground there. Now it leaves the ground, slows down, stop. What happens there at x?
It starts going down.
Yeah, but where is it now?
At the top.
Top of the second bounce. and then it goes down. And what happens at 5.13? Hits the ground again. So that time and that time, what do we know about it? Must be equal. So can you work out what x is? Yes, because you can work out the distance between 431 and 513 and just divide it by 2. Happy with that?
What if you worked out from 4,3 so you said VI equals 4.
You can. You can. But if they said use the graph too,
Yeah.
if they say use the graph too, you'll just take that distance and divide by 2. If they didn't tell you anything, yes, then you can say that G is equal to minus 9,8 and you can work out V top because V top will be 0. Yes, you can absolutely do that. Or you can use it if you've got a lot of time left after your exam tomorrow, then you can use another method to go and check your answer. That's not going to happen. Please write. Do not stare at a question. If you can't do a question, move on. Make a big star on the side, move on and come back. Don't stress about it. Just move on and come back. Okay, then, what is the magnitude of the maximum height the camera reaches after it bounced? Now, which part of the graph after it bounced? It only bounced once. Please also, if they ask you how many bounces, it hits the ground, leaves the ground, hits the ground. Only one bounce. For it to count as a bounce, it has to hit and leave. If it just hits the ground and it doesn't leave, it's not a bounce. So there's only one bounce here. So they say after the bounce, so here's where it hits the ground, there is where it leaves the ground. That's the maximum velocity. So which part is the actual second height, second displacement? Okay, it's this bit here, from there to there. But how do we get height from a graph? Area. So you're going to say delta x equals area because it's going to give you a mark.
What was our value of x?
0, comma?
No, not of x.
X.
4,72.
4,72. So now we're going to say it's half base times height because it's a triangle. So it's half, I'm just going to write base times height. And that's going to be half the base there, 0, comma? 0,41 times by the height, which is 4, and that gives you your area.
0,82.
Meters.
2.8.
2.8 or 8.2?
2.8.
I always do that.
Oh, yeah.
It's 82 now. It's 82.
Okay, so that's how high it bounced. Make sure it makes sense. It's something that hits the ground from quite a height and it bounces 0,82 is about this high. Is that possible? Why not? If it goes all the way from up in the air, I've seen a body bounce.
Yes, sir.
It was the last bounce, but it was a bounce. It was probably higher than that, but I stopped looking.
That's some that's like
A human body, man. Did it?
Parachute didn't open.
Did it die? Did you genuinely just ask? A parachute didn't open.
I didn't jump again. That was my last bounce as well. Sorry, it's not funny.
Someone's dying.
I should have known when I went there and the guy that runs the center was on crutches. I should have known. No. So they're a very good center. They just had bad luck. Okay, at time X. Now, guys, this is quite an important question. At time X, What is the distance between the camera and the hot air balloon?
Now X is after the first box, the V5.
There's X, yeah. So remember, here's the camera, it does that and it does that. So it went from here, where the balloon was at that point, and the camera is now there. But what did the balloon keep on doing?
At a constant velocity.
The balloon kept on going up at 8 meters per second.
Now, can't you just work out how far it went up, add the time, add the distance of the balloon to the ground, and then minus the distance of.
Yes, because we already know what the height was when it was dropped. What was our value there from there to there? We calculated that distance already. It was 40 point something or 30. Guys, the answer for this one 12.2, 39 point, 49 point. Okay, so we already know that that is that. But now C is here. So we have just worked out this height was 0.82. So we want to know how high the, what did they drop? Camera is above the ground. We're just going to say 49,9 minus 0.82. Then we know where the camera is. So the camera's height is, please write for us what you are working out. Sometimes you guys just do random calculations and we don't know what's what. And when you start swapping values, we can't give you anything. So 40 meters. Because we want to know, okay, so the camera was dropped from there. We worked it out in 12.2. We worked out in 12.5 that after it bounced there at point X, at its highest point, it's 0.82 above the ground. So now we just want to know what is this distance here. You didn't also have to minus it. There's two ways to do it. Okay, I see now why you asked. Yeah. So you didn't have to minus it. Let's see. So now you could have just done it. So now we're going to do it for the balloon.
Can we do speed
So-
distance time?
Hmm?
We have enough values for speed distance time for this one.
Yes, but please don't do that. You've got the equations of motion. So still use, just delta x equals vi t plus half a delta t squared. Because you are showing that you know that acceleration is zero. Because of constant velocity, this becomes zero.
We get a mark for it.
So then you're going to say delta x is equal to 8. But what is this time? It's the same. Guys, this balloon has been going, 4,72. Because this balloon has been going up, it never stopped. So 4,72, and that gives you how high the balloon is now.
Plus,
What is it?
Constant warm-ups.
37.76.
Say again?
37.76.
Meters.
37,76. That's how far it moved up. But it started here. So it moved up. It's now there. It's the 49.9
Plus, so it's 87.
plus 37,76. That's where it is now.
87.56.
87.
49 plus 37 is 87.
And then now you can say, okay, the balloon is there. The camera is here. So you didn't really have to do this part. Okay, so this part we didn't really have to do. It wouldn't really help at all. We know that the camera is there. So now the difference between there and there is the difference between them. So now you can say, can you see why it's 6 marks? It's quite a lot of stuff for you to do.
We get like 9 markers.
6, I think, is the highest, if I remember correctly.
That one last
How
night.
come I didn't get this answer?
Yeah, same answer.
I didn't get this.
Reaction time and catching up.
Okay, very low 67.
Okay, are you guys fine with this question?
Wait, now can you go back?
Oh, yeah.
So, the final answer is 87.5.
You have to add that.
Minus, okay, so they ask, what is the distance between them? So the distance between them is the 87,56 minus the 0,82.
Oh,
So it's,
if we did that other step, we would have just said,
you would have never used it.
but couldn't you have said that, that's 49, it would have been 49,08 plus that 37,760.
You could have done that as well.
I minus it from.
There's always more than one method, guys. Like here, you could have used, but please read the question. If the question says use equations of motion, please use equations of motion. If the question says use the graph, please use the graph.